Welcome to today's lecture on lightweight design. And today I want to talk about a parameter which has nothing to do with mass or structural optimization, but which is in fact one of the most important parameters, because this parameter sets up the framework for all my measures when optimizing the weight of my structure. And these parameters are the costs. So today I want to talk about the costs of lightweight design. And first of all, you have to understand that lightweight design is costly. And I want to explain to you why. Well, take the weight of a structure here on the x-axis. And you make a sizing, you make a design of your structure, so you have a first shot which with a certain weight, and this first shot produces costs. Because we have costs, of course, of the material. We have costs because we want to manufacture our product, and someone has to design and has to size this product, this structure, so we have costs of expertise. So this was the first shot. And now you want to save weight. That means you want to optimize the structure, and you start with rather simple methods. For example, well, you modify the cross-section properly to your section force distribution, for example. So with this rather simple methods, you save weight by just using less material. And this is the reason why the costs decrease. But this works only up to a certain limit. Then you see, well, now when I want to optimize on a higher level, that means I want to increase my weight savings, I have to start the sizing process with more sophisticated methods, for example with a numerical simulation or something similar. So that means I have an increase in expertise of the design and the sizing. And then I see, well, with my first material selection, this will not work, I will not reach my weight targets, I have to use higher performing materials. And of course these higher performing materials are much more costly, and it's even harder to manufacture these high performing materials, so I have a large increase in costs when I do structural optimization in terms of weight saving. So the question is, okay, well, I have this so-called weight costs curve, and the question is, what is my limit? Up to where can I go? Well, this limit is given by a management decision. And this management decision is this line, and this line are the accepted costs per weight saving. Well, and with this line, you try to find the point of the weight cost curve where this line is a tangent to this weight cost curve. And this is, for example, given here. And this point defines your weight at cost optimum. That means this sets the framework of costs for all your measures to save weight. And this is a management decision. And you have to agree on this decision right before you start with your structural optimization. And to give you some orientation, what we are talking about, well, in this range of the weight cost curve, we find our aerospace applications. And here in this range of high costs, but also of high weight saving, we only find space applications, and the automotive industry is rather here at the cost minimum. That means when you have this weight at cost optimum, you know what measures you can use in order to optimize your structure. So you will never find a global minimum of your weight, but this minimum is always related to the costs you produce by applying lightweight design. The second important question is not only how much costs can I spend in order to save weight of my structure. The second important question is when do I lightweight design and when do I commit on the costs? And here it's also important to understand that in the beginning of the product development phase, I commit on all the costs, and I want to explain you why. Well, take the timeline of the product development phase. The product development always starts with the so-called concept phase, and this concept phase ends up with the system concept review, where we agree on the concept. After the concept is fixed, we start with the design phase, and this design phase ends up with a preliminary design review. And after the preliminary design, we start with a detailed design, and this phase ended with a critical design review. And with the critical design review, the design is fixed and we can produce our structure. And after the detailed design phase, we have to qualify our structure. That means after this, we have the qualification and testing phase. And this phase ends up with the acceptance review, where, for example, authorities say, well, okay, you can put this structure into service. And here we have the costs. And now I want to have a look how much of the costs are spent. Well, take here 100%. That means all of the costs of our product development phase are spent. In the beginning of the product development phase, I have only a small team of course, high and therefore very expensive experts, and so I have a certain amount of costs, but this amount of costs is negligible compared to the costs which are produced when we go into the detailed design, where we have a lot of designers working on our design, and in the end we have a lot of tests where all the structural components are tested and qualified. So the costs increase in the end of the product development phase. So these are the costs which are spent. But the design or the expert team right in the beginning of the product development phase, they decide whether we are realizing or whether we want to realize the structure as a metal structure or as a composite structure, for example. And this decision has a high influence on the costs of my manufacturing process, for example. So this decision of a small team right in the beginning on the product development phase, this commits a lot of costs. So the costs are mainly committed in the beginning of our product development phase. So what we have to learn from this diagram is that when we want to do lightweight design, that means when we want to make a structural optimization, we can only do this right in the beginning of the product development phase, because only in the beginning we have the chance to make some changes to our structural design. Later on, when you are in the detailed design phase, you can only make small changes. Of course, not much of the costs are spent, but almost all costs are committed, and it's very heavy to make a change in this late phase of design. So the message of this lecture is lightweight design is very costly. You have to commit on the framework of costs you want to spend in order to save weight, and last but not least, you have to do structural optimization in the beginning of the product development phase, not in the end. Thank you so much for your attention.